tonight, okay? So I am going to record this part of my lecture so that um, so you get to hear me in case somebody misses tonight. This would be so important that you kind of hear me do this. Some very basic algebra. So copy this slide down. And all right. All right, hopefully you're doing okay. You just about got this copy down. So the first kind of rule here, it says in yellow up here at the top, solving equations using the addition principle of equality, okay? And the addition principle, um, I have this little note here in pink here. Add the same thing to both sides to get x by itself, okay? Um, so that's the principle, is that you can add the same thing to both sides to get x by itself. Let me illustrate it over here. If I had 2 plus, well, actually it's what I have on this first one, but let's just do the first one. I think I chose a nice basic one here, okay? All right, so we're gonna model this for you. All right, when you're solving algebra, you want to get, I'm gonna just write this note here, get x, okay, whatever x is, or it could be y, or it could be z, by itself. And once you do that, then you've solved the equation. You're trying to get x, or the variable, whatever that letter is, by itself, okay? And let's look at number 1 here. I bet you can look at number 1 and not even do any algebra and figure out what the answer is. Well, what is it plus 2 that equals 10? Your brain hopefully is going, well, it's 8. 8 plus 2 is 10, so x must be 8, right? Now, I could also have an equation if I write it over here, x plus 2 equals 6, okay? In that case, my example I've got here on the bottom of the screen here, over here, we would know, well, 4 plus 2 is 6. So in this case, x equals 4. See, it just, all x is the number that makes the equation equal, okay? Well, 4 plus 2 is 6, so x must be 4, okay? This could have been y minus 3 equals 4, okay? Well, I know that 7 minus 3 equals 4, so in this case, y would be 7. It's the number that makes the equation equal here, okay? All right, so however, I'm not gonna, what I wanna do is kind of sneak in doing some basic algebra and actually show you how there's a basic rule that's this addition rule that you can add or subtract the same thing from both sides, and use that to get x by itself. So what I want you to do is, in your notes, ideally, you might even have a different color here, okay? What I'm going to do on this side of the equation here, okay? I've got x plus 2. I'm going to subtract 2 from this side of the equation because I want to get x all by itself. And if I get the 2 out of the way, okay, then I'll have x by itself. Whatever I do to one side, I have to do the other side. It's kind of like when you're adding and subtracting fractions. Whatever you do to the denominator, you got to do the numerator, okay? So since I subtracted 2 from that side, I'm going to subtract 2 from this side, okay? So the new equation I would get, if I kind of choose a different color to kind of illustrate these two are now going to be canceled out, okay? All right. So I'm going to have a new equation that is x, because that's all that's left, equals, what's 10 minus 2? 8. We just did an algebra problem, okay? All right, so what we did was, that's why they call this the addition, or you could say addition or subtraction, but in algebra, they just call it the addition. And I'll tell you why, just so you know. They just have one rule called the addition principle. Because technically, if I added -2 to this side, and I added -2 to this side, I'd get the same thing, right? Um, so that's probably the reason why they just call it the addition principle. But look at number 2 here, okay? I bet you some of you right now could probably start doing this already. What do I need to do to get the y by itself? You know, 10 minus y equals 7, okay? All right. Um, 10 minus y equals 7. I wonder if I copied this one down right. If I subtract, if I subtract 10 from this side, okay, because I want to get 10 all by itself. So I'm going to subtract, I wonder if it was supposed to be y minus 10. Y minus, no, that's right. And if I'm going to subtract 10 from that side, I'm going to have to subtract 10 from this side, okay? Whatever I do to one side, I got to do the other. So what I'm going to have is these two, again, if I choose my different color here, these two now are canceled out. So I now have minus y equals, okay, what is 7 minus 10? If you remember from our integer study, that would give us -3, okay? Now, if I wanted to get y as a positive, you always want y to be expressed as the variable to be expressed as a positive. If I multiplied -1 times y, a negative times a negative, you know, times this would give me a positive y, and then a -1 times a -3 would give me a positive 3. So y equals 3. Now, I bet you I lost a couple of you right there when I added that in. So hang in there. We're just going to go to another example. This should be a plus right here. I'm not sure why I put a times there, but 2 plus x equals 16. Okay. All right. What do you think you do? Well, we need x by itself. So what I'm going to do is I'm going to subtract x or 2 from this side. So I got to subtract 2 from this side. And by the way, when you do your algebra, it's probably a good habit. In fact, I know it's a good habit to get used to writing it all out like I am, because I know you can do some stuff in your head. But the reason why you want to get in the habit of writing it all out is because you're going to start progressing in an algebra class to a little bit more complicated and more complicated. And if you're not in the habit of writing out all your steps one at a time, each thing on both sides, you start making mistakes. Okay. So what's going to happen therefore is that these are going to now cancel out. Okay, these cancel out. So I've got x equals, what's 16 minus 2 is 14, and there's my answer. I have solved for x. Okay. Um, and you know, 2 plus 14 is 16. Okay. So that's the addition principle of equality. We're make equal has the word equality has the word equal. We're adding something to both sides to make them equal. But really the main thing we're trying to do here is right here. We're trying to get x by itself, or the variable y, z, h, whatever it happens to be by itself. And then we know what h equals or what x equals. All right, let's go on and do some more. Okay, a couple more. I would like you guys to try 4 and 5 now all by yourself. You know what? Forget about 5. It just occurs to me. We're not ready for that yet. Just do 4. I'm going to erase this. Okay. Hopefully, give you another 5 seconds. All right, this is what your page should look like, okay? You should realize I'm trying to get x by itself. So, and I got -4. I'm going to add 4 to this side. So I'm going to add 4 to this side, okay? So I now have these two cancel, and you don't have to write this out, this canceling out thing here, but I just visually want to show you this, that these now become canceled out. So I have x equals 10. Okay. All right. So hopefully you guys kind of got that. All right. Hopefully we're doing okay so far. These are doable. Let's have you pick any two of these, and just do any two of them. And if you like, you can copy them all down, but I want you to try in the next 60 seconds to do any two of them. And you know what's kind of exciting? We are doing algebra. We're doing algebra. See, that wasn't so bad. I snuck it in on you. Hopefully. All right, I'm going to give you another 10 seconds here. All right. All right, so the first one, I'm going to use the addition principle. It's this one. I'm going to go back a slide here too, okay? I'm using the addition principle of equality. This principle, okay, this principle is that whatever I add to one side, I have to add the other, and it's a way to get x by itself. And I will remind you that I can add a -2 or I can add a +2 to the equation. I'm in a sense adding the same. I'm adding the same thing. Okay. So the first one, I see that I've got x plus 9, and I need to get rid of 9. So I'm going to subtract 9 from this side, subtract 9 from that side, and get x equals 9, 10, 6. Okay. X equals 6. Okay. Next one, let's do 6, 7 here. I've got x plus 11. That's the same thing. Subtracting 11 from both sides, I get x equals 32, 22, and one more is 21. Okay. All right. M minus 7, I'm going to add 7 to this side. I'm going to add 7 to this side. I get M, let me make sure that this makes sense, equals 30. Because 7 plus 23 is 30. 59 equals 27 minus x. Okay, don't be thrown off. Don't be thrown off because the x is now on the other side, although this will be a little bit confusing like the one I gave you on the other side. First thing I would do is I'm going to subtract 27 from this side to get rid of it, because that's a positive 27. So I got to subtract 27 from this side. So I get 32 equals -x. Okay. Now, because of this, yeah, that makes sense. I told you before, we don't want to have a -x. We always want it to be a positive. And you know the rule that a minus times a minus equals a positive, okay? So if I multiply 1 times x, it stays the same. 1 times 5 is 5, right? So if I multiplied this side times, I'll put it in parentheses, times, whoops, I didn't mean to say, times -1, okay? Then I got to multiply -1 times this side. This is kind of leading into the next principle, by the way, okay? So this -1 times a -x is a negative times a negative gives me a positive x equals, okay? And then this just turns this to -32, okay? Now, if we kind of test our answer, okay, you got 59 over here equals 27 minus a minus x. Well, a minus becomes a plus. 2 minuses there. And if you add 32 and 27, what does that give you? Does that come out to 9? Yeah, that comes out to 59, okay? All right, so Forgive me here for this one here because it's got that minus thing in it again. But it's kind of a way of sneaking in something that's coming next, I think. No, here's a couple more practices. Um, let's do this. For the sake of time, I don't want to run out of time. I'm going to let you, you guys have a packet in your class for this week that has a whole bunch of these practice ones, okay? Tell you what, I'm just going to do one or two of them real fast. Let me not do a minus one, or do they all have minuses? Let me show you number 12 over here, okay, guys? Just so you can see it, you can kind of watch me think this thing through. I've got 3 plus 11 equals x plus 4, right? I'm going to combine like terms here. 11, 12, 13, 14 equals x plus 4, okay? Now, I'm going to need x by itself. I'm going to subtract 4 from this side. I'm going to subtract 4 from this side. And I'm going to get 10 equals x. So or x equals 10, okay? So that is how you could have done one like that. Let me show you 13 here. Actually, 11 is fine. I'll just do 11. 12 minus 2 equals d plus 7, right? That's real similar to what we just did. 12 minus 2 is 10 equals d plus 7. Notice I'm just writing out all the steps. I'm subtracting 7 from this side. This is, whoa, what did I do? This is a 10 here. I'm going to subtract 7 from this side. I'm going to get 3 equals d, or d equals 3. Same thing, okay? All right, we're going to move on to the next principle here, I think, real soon. There's another practice one, but yeah. All right, hang on a second. Division principle. All right, so yeah, I'm going to give you a minute to copy this down. It's actually technically called, and I know this is going to sound really strange to you. It's really technically called the multiplication, okay? Technically, that is the correct name for this. Uh, Multiplication, I've probably got a C in there. Multiplication principle of equality. But I changed it in preparation for tonight because I thought I didn't want you to get lost with the wording, but once you understood the principle, then it becomes kind of easier. But I wanted to make sure you had this. So this is called the multiplication, or in this case, we're going to think about it as division principle of equality. Okay. So I'm going to give you another 30 seconds to copy these 4 problems down, and the rule, all right, the principle is that we divide both sides by the same thing to get x by itself. It looks like we're doing pretty good for time here. That's good. All right. Give you another 10 seconds, and then we're going to jump into some things here. Okay. All right, I want you to start by looking at the bottom of the screen down here where I have my yellow dot moving back and forth. If you had the number 2, okay, let's just take the number 2, and you want, that's technically it's 2 over 1, right? What would we multiply 2 by to make it 1? You know, 2 times what number would make it 1? Does anybody happen to know? Okay, a hint. Think reciprocal. Okay, okay. So if I multiply 2 over 1 times 1 over 2, okay, that's the reciprocal of it, I get, watch if I just do the math straight across, 2 times 1 is 2, 2 times 1 is 2. 2 over itself, anything on top of itself equals 1, okay? If I had, I'll give you another. If I have the number 4 here, okay? And I wanted to turn that into a 1, okay? So, because I want to get x by itself, I want 1x. 1x is just the same as x. So I'm going to multiply 4 over 1 times its reciprocal, okay, which is 1 over 4, which will give me 4 over 4, which equals 1. Okay, it might be a good idea for you to kind of write that down. Um, Now let me show you another example, okay, one more example. If I had, look at this. What if I had the fraction 1/3? Okay. Now, if I want to turn a fraction into 1, okay, what am I going to multiply it by? I'm going to multiply it by the reciprocal, the reverse of itself, which is in this sense 3 over 1, which gives me 3 over 3, which is 1. So we have this cool, that's why technically they call this the multiplication principle of equality. And I'm about to show you why now here, okay? So let's go up here to example number 1 here. And I'm going to change to the different color here. So I've got 2x equals 12. I need x by itself. I need to get rid of this 2 and have it become a 1, just like we were just doing down there. So what do you think you would multiply it by? I would multiply it by, if I kind of write it out here like this is 2 over 1. I'm going to multiply it by 1/2, 1 over 2, okay? And divides both sides by the same number. In a sense, we're dividing it by cutting it in half, we're multiplying by a half, okay? Um, so because I did that to that side, I bet you now you've probably heard me say this enough. Whatever I did to one side, I got to multiply. I got to do the same thing to the other side. Since I multiplied 1/2 times this side, I'm going to do the same thing to the other side. Okay. All right. I'm giving you a second to write that down. Now I'm going to change a different color here to show you now. Look what happens to this. This part right here, okay, because I multiplied it by its reciprocal, okay, it cancels itself out, okay, and it just becomes 1. So what I have is 1x, okay, this is a 1 here, 1x equals, okay, I do my math here, I've got 12 over 2 multiplied straight across here, which equals 6, okay? And so hopefully I'm not going too fast here, okay? I just multiplied straight across, 12 over 2 is 6. So 1x equals 6. Anytime you got 1 times itself, it just means that number, okay? So what that means is x equals 6. We just did the multiplication principle of equality where we multiplied it by a half, okay? All right, let's look at number 2 down here at the bottom of the page. Okay, I'm going to take, and I'm going to look at, I've got 7m. Do you see how they're right next to each other? That means times. That's 7 times m. That's why we started looking at the language. Equals 49. So I want to get m by itself. So I'm going to multiply 7 times its reciprocal, which would be 1 over 7. And whatever I did to that side, I'm doing to the other side. 1 over 7, okay? That cancels that thing out there, okay? This ends up canceling this out, so I just have m. I'm skipping a sum. Instead of saying 1m, I could say 1m, but I'll say it, 1m one more time, most algebra students would just skip that 1m step. And then I get equals 49 over 7. Well, 7 times 7 is 49, so it's 7. So m equals 7. We're doing algebra here, okay? All right, I want you guys to try number 3 and number 4. Let's just do number 3. because I got some minus numbers in there, but try number 3. It's kind of adding a step in there because it's got a negative number. It occurs to me that I'm going to draw boxes around this so that if anybody sees this later on and this is all they see, I don't want them to get confused. Okay. You're getting close, by the way, folks, to the point where you can start using a calculator. Where'd mine go? It's hiding. Up there it is. Where you could start using a calculator, but yeah. All right, for the sake of time, we're doing pretty good here. Give you another 10 seconds. All right, so we have some minus numbers here. Negative 64 equals 4m, okay? The first thing I'm looking at is this m here. I want it by itself, so I know what m equals. So since I have a 4 here, I'm going to take this, okay, this is 1 times 1 over 4, which is the reciprocal, okay, which will create a 1 here. It'll cancel out this 4 and this 4 here. So I'm going to have m equals, okay, and this is negative 64 times, I guess I should have done it over here. Um, well, I'm just going to do it like this. Negative 64 times 1/4. Okay, just so I'm doing the same thing to the left side that I did to the right side. Okay. All right. For negative 64, if I multiply, I've got negative 64 over 4. How many times does 4 go into 64? What is it? You got your calculator? See what you know? 64 divided by 4 equals 16. Okay. All right. So it's a negative 16. This is a negative 16 equals m. Okay. I think I did that right. 4 goes into it. Yep. Negative 16. Okay. So yeah, negative 16 equals m, or m equals negative 16. Okay. Let's do number 4 together. Okay. I've got negative 3x equals 27. I'm going to show you a little trick here, by the way, okay? I want to get x by itself. So if I multiply, I'm going to take my eraser here real quick. I'm going to change this a little bit, sorry. If I multiply this negative 3x, okay, times, okay, you guys know that a negative times a negative is a positive, right? So let's just say if I decide, okay, I'm going to multiply this negative 3 over 1 times, okay, the reciprocal, which would be negative 1/3. Let me explain what I just did there. I think you understand that I got a 3 here, so if I multiply it by 1/3, that cancels out the 3's, right? Now, the reason why I chose to multiply it by a negative 1/3, remember the rule is that whatever you do to one side, you can do the other side. So it can be a negative number you're multiplying or dividing, okay? I chose because I know a negative times a negative gets me a what? A positive x. So before I forget, I just want to make this real clear. Whatever I did to that left side, I'm going to do to the other side, okay? All right. All right. So now I'm going to keep following out my steps here. I'm just going to change color just to make it really clear. So a negative 1/3 times a negative 3 gives me a positive x. Negatives times a negative is an x because these cancel each other out, okay? Now I've got x equals, okay? I'm going to do the math over here, okay? I've got 27 times, well, if you wanted to cross cancel, I don't want to confuse you. So 27 times negative 1 is negative 27 over 3, okay? Or negative 27 thirds. All right, 3 goes into 27 how many times? 9 times. But because it's a negative, it's got to be a negative 9 times a positive 3 gives me a negative number. Remember the rule of opposites? It's only opposites when you multiply, they give you a negative number. So this has to be a negative 9, negative 9, okay? That's a negative 9 there, okay? So we're doing algebra here. Let's see what we got left next on my next slide for you all, okay? Give you a few seconds to copy that. Okay, we got some practice here. I got time. I think I have time. Just 1 second here. I know you're copying this down, but the division principle is real similar. So let's do any two of these. Okay, you can do any two. I'm going to go through all 4 of them kind of quickly, or at least. Why does that look confusing though, doesn't it? Look at number 8 there. Does that look scary? um, Yeah, we better at least do 8 also. Okay. For the sake of time here, I think I'm gonna walk you through a couple of these. Okay. I'm going to show you how I would do number 5. I've got 4.2x, okay, equals 22.68. Okay. And it's the same principle as if I just had 4x equals 22. Okay. Here's how I would do this one here. Okay. Um, I would write it out like this. I would go 4.2 divided by 4.2, okay? I'm just dividing it. This is kind of like getting into the next principle. Because you know that if I have 4x, and if I divide 4 by 4, it becomes 1. I cancel, I have 1x, okay? Whatever I do to that side, I'm going to divide to the same thing on the other side, okay? All right. So that's the fraction symbol. They're making it like a fraction. It's like you're dividing it, okay? What that does is that now cancels out the 4.2 becomes canceled out because 4 into 4 is 1, okay? So I now have x equals, okay? And then I got my calculator here, so you could use a calculator for this if you wanted to, because the principle is, um, so I would just punch in 22.68 divided by 4.2 and I get 5.4, okay? So just kind of trust me on that, 5.4. I just used my calculator, okay? So that's how I would get, in that case, get it by itself, okay? Get the x by itself. Um, Let's look at number 6 here, at the bottom left of the screen here. I got 14 equals x over 2. All right, now I want x by itself. I don't know if any of you can guess. I got a fraction. This is like having 1/2, okay? What would I multiply that by to get it by itself, to make it a 1, right? I would multiply it by 2 over 1, okay? And so it's going to be the same thing, okay? Even though I have an x over 2, I'm just going to go, okay, I got a 2 down here, so I'm going to multiply this by 1/2, okay? No, 2 over 1, excuse me, 2 over 1, okay? All right. Why did I multiply x over 2? Because I got a 2 down here, and I want to get rid of the fraction. I want it to just be x. So if I multiply this by 2, that means I got to do the same thing to this side, times 2, okay, over 1. So what happens is, if I choose my colors here, these now cancel out. So I have x equals, and I think you can just look at the math here. 2 times 14 is 28 over 1, which is just 28. By the way, when you start doing algebra, you kind of start doing things faster. And I shouldn't say the word skip a step, but sometimes you just kind of do the equation in your head and do the answer here, okay? 7 is the same thing. It looks like it's real similar here. I've got negative 15 equals x over 3. I know that if I multiply this fraction by the reciprocal, I'm going to get 3 over this, okay? 3 times that. So I'm going to multiply this side by 3 over 1, okay? All right. That will allow me to cancel these out, okay? And I now have x, okay? Because this is just like 1, or this would be x over 1, which is just x, okay? Equals, and then I got 3 times 15 is 45, and it's a negative 45, negative 45, okay? All right, I did want to show you 8 here. I've got b over negative 4 equals 6 plus negative 9, okay? I'm going to kind of do one step at a time here. So I'm going to rewrite this as b over negative 4, and I'm going to do the math on the other side first here, okay? 6 plus negative 9 is negative 3, okay? Because negative, this is the bigger number. So now I've got b over negative 4 equals negative 3. What am I going to multiply this side by to get b by itself? If you're really thinking sharp right now, you're thinking I should multiply it by 4 over 1. But if I'm really being smart, I'm going to multiply it by a negative 4 over 1. Why? Because a negative times a negative gives me a positive. So I'm going to multiply this side by negative 4 over 1. So this becomes b, okay, equals, I got to multiply this side, negative 3. I guess I'll do it over here. This is negative 3 over 1 times, I said negative 1/4. No, 4 over 1, excuse me. Okay, that's the same thing I did on the left side. I'm doing on the right side, okay? A negative times a negative is a positive. So this would be 12, okay? This is just going to give me the answer of 12. B equals 12, okay? All right, we're going to keep moving here. Go ahead and copy this down. I'll give you about 20 seconds to copy these down, and then I'm just going to walk you through them, okay? Remember I told you at the beginning of tonight's session that I was just going to walk you through a bunch together, like we're learning Spanish, counting 1, 2, 10, all the way up to 10. We're just kind of walking through it over and over, okay? And the nice thing about this is you're going to have your notes showing you how to do it, and if you're fortunate enough to have different colors of pen, it will stand out for you more clearly. All right, so here we go. I'm going to kind of move this along a little bit. In fact, I'll just do this first one because I need to get to the last few slides. 72 equals 14x minus 2x. Okay, so here's how I would do it, kind of like the one step at a time. I've got 72 equals, what's 14x minus 2x? This is the same, we're talking x's here. So that would be that'd be 12x, okay? Because we have x's, they're both x's here, okay? Um, so 14 minus is 2x, minus 2x is going to be 12x. All right. Now I have that by, I've got 12x here. I want x by itself. So I'm going to multiply this side, 12 over 1 times its reciprocal, which is 112, okay? Which means I'm going to have to multiply this side times 112, okay? And what that does is that gives me, okay, these two 12s cancel out. So I now have x equals, okay, and I'm just going to do this in my head here. I've got 72, okay, over 12. 12 goes into 72 6 times. 6 times 12 is 72, okay? So x equals 6, okay? All right, I'm going to move on to the next slide, guys, because I see I'm running out of time somehow all of a sudden. The division principle of equality, we actually already started doing it. So if I wrote in my notes here, I've still got 5 minutes, division principle of equality, okay? And I know it sounds counterintuitive, but the principle is that you multiply both sides by the same number to get x by itself, okay? So you see how that doesn't sound right? That's why I kind of changed the name at the beginning. We were already doing this on the last slide. Okay, I kind of snuck in some division principle of equality. So give you another 10 seconds to copy a few more things down, and then I will start. All right. Okay, I'd encourage you to use a different colored pen. You see I've got x over 5 equals 4. Here's what I would do. Okay, I'm going to rewrite the equation here as x over 5, okay? I'm going to multiply it times 5 over 1, okay? Equals, I got 4 over 1 times 5 over 1. So it's just 5 over 1, okay? So I'm doing the same thing to both sides, okay? And the reason, again, I multiply this by 5 is because it creates 1 here. It creates a 1. These cancel out, okay? And I now have x equals 20, okay? 4 times 5 is 20. Number 2 here, I got a 3 down here in the bottom. So what I would do is, if I just wrote it again real fast, n over 3 times 3 over 1 equals 12 over 1 times 3 over 1 equals, those cancel out. So I get n equals 36. Okay? All right. We're having fun. I hope you're having fun. I hope you're going, hey, this is kind of making sense. Oh, let's do number 3 here because it kind of is a good example of something that looks slightly different, but no, it's still the same principle. Okay, so I got 3/5 y equals 9. Okay, all right. What I'm going to do is I'm going to take this 3/5 y. What is the reciprocal? This is why you had to learn a little bit of fractions before you got into this class, or at the beginning at least. What is the reciprocal of that? I multiply this by, what's the reciprocal of 3 over 5? It's 5 over 3, okay? Equals, whatever I did to the left side, I'm going to do to the right side, 5 over 3, okay? That's why we're multiplying both sides by the same fraction, okay, to get rid of the fraction. So now, what happens here, if I kind of change my color here and point this out, these kind of cancel out. The 5s cancel out. This becomes y equals 45. 9 times 5 is 45 over 3. 3 goes into 45 15 times, right? Yep. So y equals 15, okay? All right, I think I'm just about out of time here, okay? So we did a whole bunch of these together. You have a document that's a PDF document. There's a whole bunch of these practice ones that you can work on. And I think your class has will have an answer sheet at at the end of that PDF practice document. Um, Hopefully this is starting to come to you. And if you're thinking, yeah, you went through a lot tonight, it's kind of going in my head, it's kind of mixing up. That's why we practice things. That's why you do homework. In fact, math is the class where you practice things the most so that they stick the most. And so, because the more you do this, the more it just starts coming. It's like doing a puzzle. Okay. All right. What I'm going to do here is I'm going to stop that and I'm going to turn off my recording. Let's see.